Okay, let's look at practice C. And let's do number 3, because number 3 has. So number 3 says, during a rodeo, a clown runs 8 meters north, 55 degrees north of east, and runs 3.5 meters. Then, after waiting for the ball to come near, the clown turns and runs due east for 5 meters. So then it says, what is the clown's total displacement? So first, I want to see, okay, what's happening here? So in the first part, I'm going to call it A. So in the first part, it says that the clown runs 8 meters north. So I'm going to draw my vector of his displacement, and he goes 8 meters north. So that's A. Then in the next part, he turns 55 degrees north of east and runs 3.5 meters. So this is 55 degrees north of east, and that's going to be B. And B is equal to 3.5 meters. And then for C, after waiting for the bull to, he turns and runs due east for 5 meters. So now I have my 3 vectors. So it says, what's the displacement? So displacement is a vector quantity, and it has both magnitude and direction. So basically what I want to do is I want to find the horizontal and vertical components of each of these. So when I look here at A, I need to find AX, and I need to find AY. So AX is equal to 0, because it has no horizontal component, and AY is equal to 8 meters. Now for B, B has a horizontal and vertical. So from where I start to where I end up, this is going to be BX. Then from the head of this vector to the tail of the other, I'm going to have BY. Now to find BX and BY, I have to, use what I know. So do I use sine, cosine, or tangent? Well, let's start with BX. BX is adjacent to the given angle. So BX is going to be B times cosine of 55 degrees. So when I put that in my calculator, it's going to be 3.5 times the cosine of 55, which comes out to be, it's about 2. And then BY is going to be its opposite, the given angle, so it's going to be 3.5 times sine of 55. So that comes out to be 2.86, and I'll just say 2.9. Then when I look at C, C is all horizontal, so CX is equal to 5, and CY is equal to 0. Now, there's different ways to do this. In the notes I showed you, just add up all your X's and all your Y's. The issue is sometimes if you have positive and negative, so I recommend making a table. So what do I mean by that? So if I have a table like this, and I say vector, and I have X, and I have Y, this is going to be A, this is going to be B, this is going to be C, and then I want to find my resultant. So I want to find Rx and Ry. So if I fill this chart in, this is 0, and this is 8, this is 2, and this is 2.9, this is 5, and this is 0. So first, now I want to add all my X and Y components. So Rx is going to be AX plus BX plus CX. So that's going to be 0 plus 2 plus 5. So Rx is equal to 7 meters. Now I'm going to do the same thing with the y. So Ry is equal to Ay plus By plus Cy, which is equal to 8 meters plus 2.9 meters plus 0. So Ry is equal to 10.9 meters. So now I have the Rx and the Ry, but I don't want Rx and Ry. I want the resultant R. Okay? So how do I do this? Well, I'm going to take Rx and Ry and I'm going to draw them. So I'm just going to push this up. So Rx is 7, so I'm going to draw a picture. So here's Rx. This is 7. From the head of this vector, I'm going to do the tail of the other. This is Ry. This is 10.9. Now to find my resultant from where I start to where I end up, and remember where I start is going to be the tail, and where I end is going to be the head of the vector. Why is that important? Well, when I need to do my direction, I always measure my direction from the tail of the resultant. So this is R, so now I can just use Pythagorean theorem. So R is equal to the square root of Rx squared plus Ry squared. So this is equal to the square root of 7 squared plus 10.9 squared. So when I do all that, I get 12.95, and I'll say R is equal to 13 meters. But I'm not done, because I need to know both the magnitude and I need to know the direction. Okay? So, how do I find the direction? I measure the direction from the tail of the resultant. Obviously, it's easy to find the angle inside the triangle. So, because I know opposite and adjacent, I'll use tangent. So tan of theta is equal to opposite over adjacent. So it's equal to Ry over Rx, which is equal to 10.9 over 7. Now when I put that in my calculator, I'm going to put 10.9 divided by 7 equals, and it comes out to be 1.57 whatever. But that's not my angle. That's tan of theta, and I want theta. So now on my calculator, I press second tan, and it says 57.29. So now theta is equal to 57.29 degrees. But that is not my final answer. My final answer for my displacement is going to be 13 meters at 57 degrees north of east. And that's my final answer. So the key to doing these types of problems is you don't try and do stuff in your head. The more you write down on paper, the less likely you are to make a mistake. So when we do this problem, the first thing is I draw each vector individually. I find the horizontal and vertical component of each vector. If I do a chart, it makes it really easy when I add up all my x's and the y's, I won't make a mistake, especially when we have ones that are like negative. Okay? And this one we didn't have any negative. Then once I get my Rx and my Ry, in order to find R, I use the Pythagorean theorem. And then every vector has both magnitude and direction. So then to find the direction, I use tangent, and then I say the direction. Now this one happens to have north, south, east, and west. Let's just look real quick that we understand the difference. So if I have north, south, east, and west, when I'm measuring an angle, I can't measure an angle from nowhere to somewhere else. So whenever I measure an angle, it always has to be from one direction to another. So if I was measuring the angle here, it has to be from a direction going somewhere else. If I was measuring this angle here, it has to be from a direction towards somewhere else. So this one is north of east. This is east of north. This is west of north. This angle here is north of west. This angle here is south of west. This is west of south. I don't see people writing this, so I guess you guys know all this already. This is east of south, and this is south of east. So whenever I'm measuring an angle, I can't just write this angle here northeast, because northeast implies that it's 45 degrees. Was the angle that we just calculated 45 degrees? No. So you can't write northeast, because this angle here is different than this angle here. Now, if I wrote 57 degrees north of east, and let's say I found a different angle, and this angle was 33 degrees east of north, do these two things mean the same thing? They do, because they're complementary angles. They add up to 90. So 57 degrees north of east or 33 degrees east of north, those are the same thing. They're measuring the same exact angle. So you have to be specific.